All right, guys, number 33 is asking us to solve this initial value problem. So they've given us our diffie-q on the left, and then we have this initial condition over here on the right that we'll deal with a little bit later to help us solve for c. Okay, so the first thing we've got to do is work on separating our variables, and it's actually not in bad shape right here. The only thing that needs to be moved is this e to the negative y squared. So I'm going to go ahead and actually divide both sides by that factor right there, since it's being multiplied by x, and that's going to do something maybe a little interesting for us on this left-hand side. So that's going to cancel with that. So what we have here on the left is a y that was out in front here. And then let's see, the e to the negative y squared. You've got a monomial there with the negative exponent in the denominator of your fraction. Well, that's just going to get brought up to the numerator right here, and that negative exponent is now going to change signs and become positive there. Now also, kind of taking some liberties here, guys, remember that this y prime is dy dx. So that's going to give me a dy here, and then I'll multiply both sides by the dx. So my right side is just going to become an x dx. And there you go. Without too much trouble here, we've gone ahead and we've separated our variables. And as soon as you do that, we're ready to go ahead and anti-differentiate both sides of the equation. But this left side here gets a little bit hairy. Why? Because we have two distinct parts to the integrand right here. But what I do notice is that the exponent on the e right here, which is y squared, would have a derivative that would match up pretty well with this y. That tells me, guys, that we are probably going to do u substitution here within an initial value problem. So I would let u equal the exponent here, which is going to be y squared. Du is then going to become 2y dy, and other than the 2, I really like that, so I'll divide that out and get a 1/2 du is equal to a y dy. So back to where I was just a second ago. I'm not ready to do my antiderivative just yet, but let's see what's going on here, guys. The primary substitution happens right here. This is now e, and the y squared becomes a u. The secondary substitution is the y dy, which we have right here. That gets replaced by a 1/2 that goes out front and a du at the end of all that. And all of that will equal, I want to just keep things at the same level right here, an x dx, and that, of course, is being anti-differentiated as well. Sorry, here we go. Okay, so now I think we're in a good spot right here to go ahead and evaluate our antiderivatives. So we're going to start on the left with keeping the 1/2 there. Antiderivative of e to the u is still just e to the u power. And I suppose at this point, guys, there's no harm in me unsubstituting or resubstituting. Rather than writing e to the u, I'm going to write that as e to the y squared. And that's going to equal, antiderivative of x is going to be a 1/2 x squared, and here is where we put our plus c. And at this point, everybody, as soon as I've gone ahead and anti-differentiated, this is when I like to kind of hit pause here and do some work. I always switch to green for this for some reason, and deal with my initial condition so that we can solve for c. So we're going to put a 0 in for x, and a -2 in for y. So this line is now going to become a 1/2 times e to the, this would be a -2 for y, but squared makes that a 4th power right there. And it equals 1/2 times an x value of 0, well, that's pretty easy, squared plus c. So all of that just wipes out. The c is already isolated, and I end up then, guys, with c is equal to, there's not much to do to this here, e to the 4th over 2, or a 1/2 e to the 4th, however you want to write that. Okay, so not in bad shape here, guys. We have solved for c. So now let me go back to where I was just a moment ago. I'll switch back to blue also, and let's keep working now on taking this equation. Didn't need to be that far down. Taking this equation here, putting in the new c value, and solving for y. So one thing at a time. We've got a 1/2 e to the y squared power is equal to a 1/2 x squared, and then a plus c we now know is e to the 4th over 2. Gotcha. Now let's work on solving for y. We'll multiply both sides by 2 first to get rid of that 1/2. E to the y squared equals, oh, and this is convenient. When we multiply everything by 2, we just end up with an x squared plus e to the 4th. Okay, moving right along. How do we get rid of this e? We're going to take the natural log of the left side, and then we'll do the natural log of the right side as well. The natural log and the e on the left cancel each other, so we get a y y squared equals. And remember, guys, it's funny because I'm going over this with Algebra 2 right now. There's no way to simplify a log of a sum. So this just has to stay the natural log of x squared plus e to the fourth. Nothing really we can do to clean that up. And the last thing we would do now is take the square root of both sides to undo the square. So we're going to get y equals, and temporarily, everybody, we've got to put a plus or minus in front of this radical here, the square root of the natural log of x squared plus e to the fourth. Now I say temporarily because in a regular differential equation, when we were not given an initial value, it's okay to leave a plus or minus in your general solution. But in an initial value problem, you were given a specific ordered pair that this original function has to contain. That means, guys, that it is either going to be plus or minus out in front, but we actually have to determine which one it is. So if we go back to the initial condition, which I can see from this line right over here, when x was 0, our y value that we put in was -2. Only the plus or the minus is going to make that work, but not both. So let's think our way through this here, guys. When x is 0, we get a 0 squared, which is 0, plus e to the fourth, e to the fourth. The natural log of that e to the fourth is going to be 4. The square root of that 4 is going to be 2. Now it's either plus 2 or minus 2 that's going to get us this y value right here. Pretty obviously in this case, that one is negative. So I'm going to erase that plus or minus and all this other junk I had right here. And now I know that my answer, the only way this works out, is if I had a negative in front of that radical. So what we have here that I'm boxing up right now, guys, is the one and only function that exists that has this original differential equation as its derivative and also contains the point 0, -2. So that is how we handle problem number, I forgot what it was now, 33. There we go.